to find the greatest term of binomial expansion, we always express the given binomial expansion, given binomial which we are going to expand in the form 1 plus x to the power n. Always you will express in that form 1 plus x to the power n. Okay. Now you will find the term tr plus 1 and then you will find tr. All of you know this is ncr and this thing going to be ncr minus 1 x to the power r minus 1, and the ratio between these two also, some of you remember that tr plus 1 by tr is equal to n minus r plus 1 by r into x. Now just compare these two terms. tr plus 1 by tr greater than or equal to 1. This implies this thing, this by r into x is, only thing you will change here, you will write mod x here because that negative, otherwise it will bring more confusion. Never do it because you are going to calculate numerically greatest term. Okay. If you see the sign minus 572 and 471, that minus 572 is numerically greater. That you have to take. That's why you have changed to mod x. This you need to simplify. N minus r plus 1 into mod x is greater than or equal to r. So just by changing the sides, you will be getting r into 1 plus mod x will be n plus 1 into mod x. So this implies that r less than or equal to n plus 1 mod x divided by 1 plus mod x. Okay. Now this may be integer, this may be integer plus a fraction. Okay. By substituting, put n and x over there. Suppose you are getting r less than is equal to m plus f. Okay. This m plus f means if you get, if by putting this n and x, if you get r less than or equal to m plus f, this will imply that term cannot be a fraction, that r will be less than or equal to m. Okay. And this m stands for a positive integer, and that fraction f, it's a proper fraction, it should be greater than 0, less than 1. Okay. Now we will discuss a common method to find the numerically greatest term, that is known as shortcut method. Here you can decide, just if you find that if this is coming to be r less than or equal to 7, then tr plus 1 will be greater than tr. Okay. So your step will be, number 1, to calculate this thing first. Find the value of n plus 1 mod x by mod x plus 1. Okay. Find this thing. To find the greatest term, we will follow this procedure. Calculate this thing first. Step 2. Suppose this thing is coming to an integer. If this is equal to, find this thing. You just write case 1. If n plus 1 mod x by mod x plus 1 is an integer, then Tm and Tm plus 1 are equal and both are greatest term. And suppose this is not an integer. If this is not an integer, if m doesn't belong to the set of integers, then T modulo m plus 1 is the greatest term. Okay, this modulo you know very well, that is the greatest integer function. Now let us apply in sum, because this how Tm and Tm plus 1 are equal and both are greatest, this will otherwise bring confusion among you. So let us find the numerically greatest term in, just take this example, find the numerically greatest term in 3 plus 2x to the power 10. Okay, to find the numerically greatest term, I told you first you will express in the form 1 plus x to the power n. Here you take 3 to the power 10 common. 1 plus 2x by 3 to the power 10. Now we find n plus 1. You can go by direct method also. Just by comparison you can get. Otherwise you find this thing, n plus 1 2x plus 3 by 2x by 3 mod plus 1. Okay, this when x equal to 3 by 2. Find the greatest term when say x is equal to 2/3, 3 by 2 something like that. So you find this thing first. N plus 1 means 10 plus 1 into 2x plus 3 . Just evaluate this. This is going to be 11 into 4 by 9. 4 by 9 plus 1. So this thing going to be, we'll get some funny result, because here this is going to be a fraction, no? And it is quite obvious that the first term will be the greatest one, because it is giving us 3 to the power 10. Without any calculation you can state, because I have taken a bit what to say, some which is not suitable for this discussion. Okay, let me finish it. I have started this. Mentally I said the sum. This is coming 11 by 3 unfortunately, which is a proper fraction. So what will be our answer here? If this is a proper fraction, this is the integral part is not there. So which one is the greatest term? T 11 by 13 plus 1. 11 by 13 modulo is 0 only. So T1 is the greatest term. Okay. So this you could have decided in the beginning only, because x is 2 by 3. But the problem arises if the same sum I have taken x is equal to say 5 by 3. Just I am changing a bit. Solved. By taking x equal to 5 by 3. Then how do you find? N plus 1. T1 is the greatest term, means here it will be 3 to the power 10 only. Answer. here n plus 1 into mod, let's see the value of this. Put x equal to 5 by 3, 11 into 10 by 9, that is 10 by 9 plus 1. So this is going to be 110 divided by 19. Now fractional part of 110 by 19 will be what? This is going to be 9. No, this is 7, I think. 7 into 70, no, not 7, 6. 60 plus 54, yeah, 6 or 5. This is going to be 5. So therefore, T5 plus 1 is the greatest term. See, it changed. T5 plus 1, this you can find easily. It will be 3 to the power 10 multiplied by 10C5, 2x by 3 to the power 5. Put the value of x there, you will get the greatest term. Let us take one sum where this will be an integer. Then our decision making will be easier. You just take this example. Find the numerically greatest term in, say I am taking a specific sum, 3 minus 5x to the power 11. Here definitely you will get an integer case. So you all can start this one. How to find the, what is the numerically greatest term when x is equal to 1 by 5. Find the numerically greatest term in the expansion when x is equal to 1 by 5. So start solving. This again we are going to arrange in the form by expressing in the form 1 plus x to the power n. Similar procedure. So this will write 3 to the power 11, 1 minus 5x by 3 to the power 11. Okay. We never calculate that all those tr plus 1 because we know this thing we have to calculate. N plus 1 mod x by mod x plus 1. We will find that one always. So we find n plus 1 mod x by mod x plus 1. Okay. That n is going to be what? N is 11. So 11 plus 1 mod this by 5x by 3 plus 1, 12 into this plus 1. Okay. So this is going to be 12 by 3, 1 by 3 plus 1, that is 12 by 4. This is equal to 3. Now see for integer how to solve, because previous two sums we did it for fraction. Here this thing we got from the consideration that tr plus 1 is greater than or equal to tr, and the final result is r less than equal to 3. So this I am repeating here. So tr plus 1 by tr is greater than equal to 1, that is tr plus 1 greater than equal to tr if r is less than equal to 3. So long r is less than or equal to 3, this will happen. So what will happen there? That tr plus 1, I mean T4 and T3, this will be greater than T2, this will be greater than T1, and this will be greater than T5, greater than T6, this manner. So therefore, that's why we draw the conclusion that T3 and T4 both are greatest term. So T3, T4, they're equal, that's why both are greatest term. And the value of T3 is going to be just a T4, that is 11C3, then 3 to the power 11 NCR e to the power n minus r x to the power r. So this to the power 3. You take it positive. Just evaluate this. Sum is done. Okay. 11C3 into 3 to the power 11 into 5x to the power 1/3. No negative sign because you are finding numerically greatest term. This will be 11C3, 3 to the power 11, 5 by 3 into, what is the value of x here? The value of x is 1 by 5. Cube. So this is 11C3 into 3 to the power 8. This is the answer. Okay. So all of you have understood how to find the numerically greatest term. This is clear. Now the thing is how to find the greatest coefficient. Okay. We'll follow the same procedure. When if here in this case just two cases will arise, n is even or n is odd. Numerically greatest term will occur for r is equal to n plus, for r is equal to n by 2 if n is even, and if n is odd there will be two greatest coefficients, that nc n minus 1 by 2 and nc n plus 1 by 2. You can prove it by same manner. Okay, the greatest coefficients. Wait a minute, I changed the section here. Okay, we do it here. Greatest coefficients, that out of these nc0, nc1, nc2, ncn, which one is the greatest coefficient?
So it depends if it's even or odd.
Yes, it depends on n is even or odd. So we'll find that we will start the same manner, that let coefficient NCR plus 1 is greater than or less than equal to NCR. From there we will reach that result. So I'm not going to derive that. When n is even, when n is even, the greatest coefficient NC n by 2, when n is odd, the greatest coefficient will be NC n minus 1 by 2 or NC n plus. This is a very useful fact. Okay, and if you remember this fact, then you can write the answer in one step only. Okay. So now let us just decide which one is the numerically greatest coefficient in, say, 1 plus x to the power 21. Here numerically greatest coefficient will be here 21 is a odd number. This will be 21c. The answer is 21c10. Okay. Or you'll, if you write this one 21c11, see by property only it will be the same. 21c11 is equal to 21c10 only. Okay. So both are greatest term over there. This fact you keep in your mind. Now we'll study some properties of binomial